And so this workshop is brought to you by IETE and in association with Pantech. So to say about Pantech, Pantech is in the field of engineering from 2004, and there are lot of events going through Pantech, and even this webinar is from Pantech. To say around 1200 workshop have been conducted by Pantech, and about 250 faculty development programs, and more than 8.5 lakhs students have been benefited with the services from Pantech from the year 2004 till date. And more importantly, the value added courses which Pantech is providing to students will be useful in their career, like getting a jobs and moving to core side or the desired technology. And Pantech is having its own R&D centers in Chennai. Uh, and Pantech is in the field of software, electronics, and electrical and mechanical, and all the technologies related to these fields which are mentioned here. So we can able to get services from all these technologies from Pantech. So in uh, the webinar is brought to you by IETE, as most of electronics, especially from telecommunications, might be members. Even I'm a member of IETE. Uh, it have been organized in 1953 with more than 1 lakh 25 members in it. And this specific webinar is from IET Mumbai. Okay, so to get the things up, so today in this session I will discuss about a machine learning model. I guess all of you know about machine learning, what it is, and how we are processing data and all the sequences, or at least you know what is machine learning, what is going, like what is the recent trends in machine learning. So I don't want to like extend all the things and explaining everything, because it's already in your hands. The machine learning applications are with you. So today we'll discuss briefly about machine learning, and what are its types, and process, like what and all process will be implementing, like all the steps and all, and applications which we are using currently, and the Python libraries which we will be using to implement these, and the algorithms. Okay, yeah. So regarding machine learning, okay, so everything in a machine learning, uh, as the name suggests, learning, right? So it is nothing new. It starts with human thinking. So the intelligence what a human acquired is through experiences, right? So in our day-to-day life, all the experiences are useful to us. Even the positive experience and negative experiences both are useful, right? So in the same way, machine learning is a concept where we design a model which takes input data. Data is nothing but an experiences as an data, and will try to develop a model which can actually try to predict what will be, like predict the outcomes which are going to happen, just like we humans we are thinking, right? For example, now I'm taking a webinar, and there was a noise, some vehicle going by. So I know what kind of vehicle is it, a two-wheeler or four-wheeler, because with my experiences. So the sounds which I've heard previously, with those experiences I know what was the vehicle is about. So in the same way, machine, we can able to enable the machines to think in the same. Okay, so it is nothing like to adding a intelligence to a smart device. Okay, so currently we are having all smart devices like our mobile phones, tablets, and everything. So now through machine learning we are trying to enable the intelligence in them. Okay, yeah, that's what machine learning. Now I can represent you. So maybe all of you have some basic experiences with any kind of programming, right? So, or even forget about programming. Everyone have did math, right? So if x equals to 1 and there is some rule, like it could be a line, right? So y equals to x into 2, for example. So we will be predicting y depending on x. Okay, so if x is 1, y will be 2. If x is 2, y will be 4. So now what if x is very complex? Okay, it is not straightforward like integers, or we can't derive directly. So machine can't directly process this, right? So we can't directly program anything which where we will be predicting some output. Okay, so that's what we will be creating a model. So today what we'll try to see is we'll take some model. Okay, and we are having lot of experiences, I mean like the data sets, but I feel like coronavirus is trending these days. So why can't we take the data set of coronavirus and let us try to see like what kind of data, how the data is, and we'll try to plot some data, and we'll try to predict some results through our model. Okay, so model is nothing but, you can think it of like a uh, model is nothing but a rule, okay, where you give some input to that rule and you'll get some outputs. Okay, so that model, these models all have been defined already in libraries. Okay, so there are a lot of libraries available. So today what we'll discuss is we'll try to see the default model which are already available, and parallelly we'll try to create our own model. Okay, so we won't be using anything which are defaultly available. We'll try to customize a machine learning model, and we'll try to apply that to the data set. Okay, and we'll try to see what is the error percentage, and uh, how much more accuracy we can able to achieve. So all these things. Yeah. Okay, so basically terminologies in machine learning, these are very few, like there are more terminologies, but to cope up with the things, a data set is nothing but, you can think it of, data sets are nothing but a experiences. Okay, and for example, uh, all these days daily in the news we are listening like so and so many cases have been like today these many cases in Telangana have been positive, and so many cases have been cured, and so many people have been dead. Okay, so not only Telangana, like all the states in India for that matter, and even worse around the world. So we are having this as an experience, right? So today, on this minute, whatever the data we collected is an experience. So that we have to collect in a CSV format or text format or in any database. So that we call as a data set. Okay, now features. So features are nothing but how we are like interpreting, like how we are putting this data as per the features. Now for example, one of the feature is like states. Okay, so like Kerala or Tamil Nadu or uh, Telangana, Andhra Pradesh. So these are the features. So as per this state, what are the casualties, I mean like what are the positives, what are negatives, what are cured, or how many people death. So all these we call as a features. Okay, now finally a model is nothing but a rule. Okay, so the rule which predicts output with an input. Okay, so basically model is like, just now we have seen one example, right? Y equals to x into 2. Okay, so in the same way we'll try to create our own model. So applications, I guess we are currently having all these. So we've been watching a lot of Netflix sequences all these days, which will be suggesting users depending on their previous watch history, even YouTube for that matter, or Facebook. And these services like Amazon, Uber, and FIFA, EA Sports, like all these, depending on the user inputs, whatever they have been previously been gone through, they'll be suggesting to users. okay, and you can have real life gaming. So I can say number of applications which already I guess you people gone through or you've been using all these days. Okay, so to go inside machine learning, so now machine learning, there is vast, like machine learning is very vast. So to classify generally in machine learning, there are three stages: supervised, unsupervised, and reinforced. Okay, so supervised, as the name suggests, supervised is nothing but it is a learning process where someone are guiding you. Like now, for example, you are a student and you have a faculty. Okay, now faculty will be guiding you, like whatever the mistakes you are doing or what correct answers you are giving, right? So there is someone who are guiding you and who are correcting you, or who are reducing you the error percentage and giving you the accurate results for that matter. So where in supervised learning, we will be having uh, predefined before getting results, we have actual train set and test set. Okay, so with that we'll try to train a model and then we'll try to see the predict the results. Okay, now regarding to unsupervised learning, as the name suggests, unsupervised, so nothing but there won't be any model or something which guides you. Okay, so it's up to us in order to reduce the error percentage and to get the accurate results. And whereas reinforced learning is something like which will be learning with continuously. Okay, for example, if you have put a mice in a grid or something like that, so if mice will be moving here and there and it will be trying to learn what kind of environment around it, and it will try to in that mesh it will try to find a way and it will go out. So it can't able to happen directly, it will be a step by step process. Okay, so which each learning it will try to improvise the results. Okay, yeah, supervised learning, where we'll call it as a labeled. So in supervised learning, there are two things. One is classification, one is regression. Okay, so classification is nothing but, now let us suppose we have fit a camera in a road and we want to count like red cars and blue cars. Okay, and we have did some image processing model where it detects a car and it counts blue car and a red car. Okay, that is like classification. Okay, now regression is nothing but, now we'll see for example, we can see the same data set as a coronavirus, as number of days are increasing, so and so positive cases are getting increased, right? So there is some linearity in it. Okay, so depending on the data we have to see which model we have to use. Okay, so generally there are two. Yeah, so as of classification model, there is one line, so above and below, so good or bad we can able to classify. And as per regression, how much closely it is as per the axis. Okay, okay, unsupervised learning, now you can see in your left side there are some diagrams, right? So there is no rule. Okay, so our model have to detect the data set and it have to classify the objects in the data set as per they are like circles, squares, and triangle. Okay, so this is unsupervised learning, so there is nothing, no rule initially, or there's no guidance. Okay, or I can say it is unlabeled. Okay, so we have to be labeling each and every uh, feature, and those features, through those features we have to classify them. Okay, and whereas reinforced learning is nothing but it depends on the rewards. Okay, so nothing but, as I said, positive experience and negative experiences. Okay, so with reinforced learning it will know how much positive, like if we are going with this path, how much positive experiences we have, and the other path what negative experiences we have, and with overall thing it will try to increase the reward points and it will try to get to accuracy. Okay, so these are generally three type of classifications, and now we'll see overall process, like what we'll do, what machine learning model will do entirely. So step one is like data collection. Okay, data collection, as you know, Now, for example, not only coronavirus, you can take anything as of that matters. Like you can take employee salaries or any data, right? We are having a lot of data around us, so we can directly classify all the data and we'll collect the data. So there are a lot of ways to collect the data. So it's up to the user how they are doing, and there are a lot of internet sites where the data is already been present. Okay, so for this matter, in coronavirus, like in most of the government sites, they are providing this data. So we can go to those sites and we can collect and we can arrange the data in an order. And next is the data preparation. Okay, so I feel to yeah. So coming back for the data, so data collection we can do with a number of ways, and data preparation is the important thing, because there will be a lot of data where a lot of junk or null characters or unwanted data or unintended data will be present, because there will be huge number of data collection. So we have before fitting a model or before giving any data to a model, we have to do data preparation, nothing but removing unwanted things and making the data proper, okay, in a systematical order. Now as the data is ready, okay, we have to uh, give that data to a model. So directly we can't able to pass the data to a model. Before that, we have to visualize what kind of data it is and how the data actually being presented. Okay, because for example, uh, if the data is as per states, okay, and like one column is states and other column is something like dates and all. So we need some pre-processing in order to like compare these two things, okay, or merge or pass these two features to our model. Okay, that is called data pre-processing. For that pre-processing, we have to visualize the data first of all. Okay, so now as we have visualized, then we know actually how the data is and what will be the proper uh, fitting model. So as per the fitting model is nothing but it always depend on the user. There is nothing pre-specified models for a data. I mean, like as I said before, red car and a blue car. Okay, for this obviously we'll be selecting the classification model. We don't have to go with regression, right? Now after like uh, what I'm saying is it's up to the user to select what is the best model. Okay, and even we for that matter we can take multiple models and we can able to get we can compare their accuracy. So finally whatever the accuracy is matching, that we can able to continue. And after that data like model evaluation, as I said, all the processes. Now after evaluating, we got some accurate like some result. Okay, now that result may not be 100% accurate, right? Because there is no model which can accurately give results for any kind of data. Okay, so what we have to do is we have to do some tuning. Okay, so nothing but we have to use we have to change some parameters and we have to overdo all these things, okay, in order to reduce the result. Okay, so finally after some fine tuning, so particular model will be working properly for some kind of data. Okay, so I repeat it, there is no model which accurately gives data which accurately predicts output for any kind of data. Okay, so there is no 100% accuracy. So for that we have to do some fine tuning in order to increase the accuracy. Okay, so these are the overall process. Now I hope it is fine, clear to everyone, right? So if you are having any doubts, these are theoretical things which I have said till now. uh, uh, After this we'll try to see like what to load the data and to visualize the data, to prepare our data and to make our data to fit our model, all these things. So there is some stuff coming through. So if you are having any doubts in this process, you can ping in the comment section, okay, right now, or whenever you're having any doubts. So I have a few of my friends who will be like replying to you. Okay, if you are having any comments, please do. If you are having any doubts, please do comment in the comment section. And finally, if you still have some doubts which need some extensive explanation, or if you need some documented based explanation, you can always mail to us. Okay. Okay. Yes. So we have seen what is the process. Now we know the process, right? But we need some language where we can able to implement all these things. Okay, so there are a lot of languages like Java, R, like many things. Okay, but here I have chose it to be Python. So not only Python, you can select any language, but why I have chose Python? It is very user friendly and easy to learn language, yet it is very powerful. But only disadvantages of Python is like the execution time of it. Okay, so okay, and okay, so for today in Python there are a lot of libraries. If you are choosing Python, in every field we will be having its own supported libraries. Okay, for any simulation or whatever the tool it is, we can use Python. Okay, so currently for today we'll try to use these libraries: pandas, numpy, matplotlib, seaborn, and sklearn, and we'll try to import them, and we'll try to see. And the participants who are not aware with Python previously, they are like, we don't have to worry with it, because you just have to go with the flow, like how the Python is, because the syntax of Python is not that difficult. It is very easy. You just have to see what and all, like what and all going through, what, how the list members are, what data it is flowing. That's it. Okay, so again, I'm ensuring it is very easy. Okay, so today we'll see gathering the data, importing package, data visualization, and pre-processing and model selection. So these and training and evaluation. So these 8 steps we'll try to implement for today with the predefined models available, and with our own user model. Okay, we'll try to customize that model. Okay. Okay, so in order to do all these, there are a lot of frameworks available. For this, I have chose it to be Anaconda. Okay, so you can straightforward download Anaconda uh, in Anaconda site. Okay, so it is supporting for Windows and Linux, or even Mac. Okay, whatever your PC configuration, you can directly download it. Okay, so in Anaconda there are some more frameworks. Here I'm using Jupyter. Okay, in the meantime, depending on your application or depending on your data, you can able to use anything. Okay, so I'm simply trying to launch it. Okay, when you click on this launch, it will open up in your browser. Okay, okay, we'll try to see this. If any doubts till here, you can ping that in comment box. Okay, like I'll be waiting for 10 seconds. Fine. So if you are still having doubts, you can pass it in comment section. My friends will be replying it to you. And still, if you have any doubts, you can finally mail it to me. I'll be giving my details to you. I can forward the like documented explanation to you. Okay, yeah, we'll get started. So here in Jupyter Notepad, what we have is like individual cells. Okay, just for description, just like a comments in your normal compiler, we can say. Okay, here import is nothing but it's like include. So we'll be including header files in C program or C++ or Java, right? So in the same way, we'll be importing libraries in Python. Okay, so NumPy, which is numerical Python, I will be using NumPy in order to take a data, like a chunk of a data, and to process it to like what we say, like to extract some data and to fit it to some other. So it will be useful in order to like adjust the data as per our requirement. So and Matplotlib, as the name suggests, it is useful to plot graphs. Okay. And pandas, so pandas also we can able to process the data and we can able to fit the data as per our requirement. And sklearn, scikit-learn is the initial model for every beginner to go through. Like this is a library where you have all the models predefinedly available. Okay. Yeah, now in the step one we'll try to use the predefined model, and step two we'll try to create our own model. Okay, so that's what I will do. Okay, so now I'm having one CSV, nothing but comma separated values, which is an Excel. uh, you can create your own data or you can able to download, as I said. Okay, here I have downloaded data from Kaggle. Okay, you can directly go to Kaggle and search for COVID-19 data set. Okay, you'll get that. So what I'm doing is panda.read, I'm reading that. Sorry. So we need to execute. The star represents like it is in process. Yeah, we have read the data. Now data.head. Okay, so nothing but I'm trying to represent like 10 entries which are in that Excel. Okay, so the data is as such, like serial number, age group, total number of cases reported, and what is the percentage. So this data actually says like what and all age group and what is the percentage we have received. uh, I just need a minute. Okay, I got a comment like it is not visible, so I'm increasing the size. Yeah, in the same way, like whatever the discussion point you can put in comments. Okay, I guess now it is visible to everyone, right? Okay, now we'll see. So this is the data which we have received. uh, so as per the age group, as we can see, there is a percentage. Okay, but as we know, like there is some misconception, uh, like here or how the data interpreted is like there's 24% coronavirus can affect to age group of 20 to 29, but it is not as such. How why the data is presented like this is the population is more in this age group, so that's why the percentage is more here. But corona is going to affect more for the people who are like elderly, like above 60. Okay, so why the percentage less here is like obviously they won't be roaming outside, and the population count will also be less with that much that age group. Okay, so that's what the data presented here. Okay, which doesn't mean it affect to elder people. Okay. Okay, so this is what the data. Okay, now we'll try to see in our own mathematical terms how the data is. Okay, so if we run this data.describe, we can able to see how many count, like there are only 10 counts, mean value, standard deviation. So all the values whatever we needed. Now we'll instead of directly seeing it, we'll try to visualize the data. Okay, so what how to visualize the data is, now this is the data, right? So if I need this number or this age group or anything, we can able to pass on these tags. Okay, so data of age group will return me all these data. Okay, so data of total class will return me all this data. So that's what panda will be useful. So through pandas we can able to read any column or any row or specific columns and rows or whatever we can trace in that way. Okay, so here what I'm doing is, so serial number, why I have took serial number is like you can take age group. So this one suggests like 0 to 10 years, 2 is like 0 to 20, 3 is like 0 to 13, that way. Okay, so now we'll try to predict something like for what and all age groups how many cases might get. For example, if the person's age is like 45. Okay, how many cases might be in there for age group of 45. That's what the prediction will try to do now. Okay. Okay, so before predicting anything, we'll try to see the data. So plot.scanner. Okay, so we'll try to take serial number in x-axis and total cases in y-axis. Okay, and we'll try to name it like age of people and the total confirmed cases, and title I will put it corona with age prediction. That's very simple, right? So this is the plot. Okay, I'm giving x and y axis. That's it. Simple. Okay, when we are running it, we'll get the data. Okay, so from 0 to 100 years, this is into 10. Okay, so this is how the data is. So as we can see, the percentage of coronavirus is more in this age group. Okay, so this is what the data is like. Now now what we'll try to do is, as we are having this data, okay, we need in order to predict something, we need a testing and training, right? So what we'll do is, we'll try to divide the data 80% into training and 20% into testing. So we'll try to split the data randomly, and then we'll try to uh, predict the outcome, okay, with the model. Now data dot values, which returns actually what kind of data we are having. Okay, and now I'm taking one variable m in order to like reshape my data. Okay, so I'm taking 0th uh, column and second column. Okay, which mean I'm taking this serial number, which represents like 0 to 50 or 60, 70 in that way. So this and number of cases. Okay, so I'll try to use this function train test split. Okay, so yeah, so what I'll do is, I'll try to take 20% into test set. So obviously 80% will be in train set, right? So this is a function which takes x and y as an input, and it takes percentage as an input, and random state at what random state it I have to take. Okay, if I'm taking 0 from 0 at any random, it will spread the data. So I'm just running it. So this function will return four types. One is x elements of a train, x element of test, x element of train, x element of test. So now what we have is, we have train set and test set. Okay, we'll try to see how the data is, what is train and what is test. Okay, so if I put x train, so randomly the data have been arranged, right, from like the ages like 50, like 100, 20, 70, 80, 40, 10 and 6. Okay, so this is train, and see we'll try to see what data we are passing to test. So this is a test. So we are trying to test for the age of 30 and 90. Okay, the same way uh, so these are the y values with respect to x values. Okay, in the same way we can able to get a y test also. Now the procedure what we'll do is, we'll try to train our model with x train and y train. Nothing but, if this is input, this will be output. That will say, okay, we'll try to create a rule for this input, that output, and finally we'll try to test our model with this input, and it will try to result something, right? That results will try to compare with this test. Okay, so with that we'll get how much accurate the results are. Okay, I'll try to explain in depth when we are seeing the algorithm explanation. Okay, so in scikit-learn we have this model linear regression. Okay, so it's the basic first model, I could say. There are many number of models available. Okay, so as the data is like linearly increasing or decreasing, we can use it linear. Okay, so linear regression, I'm taking it into a variable. Now I'm fitting the model with a trained data. Okay, so with x and y, which returns uh, like these are its arguments. Okay, normalize is false. Okay, and fit interception is true, and copy is true. So now, as a new to machine learning, you might not be knowing what are all these are. Okay, and even if you're using these predefined models, we can't customize. Okay, we can't normalize it, or we can't do anything on our own. Okay, that's why we'll try to create our own model. Okay, so after this we'll try to see how it goes. First we'll see the predefined model. Okay, so this is a model which is nothing but rule. To this rule I am giving my input x and y. Okay, now the rule will be set for this data. Okay, now directly we are having predict. Okay, so as the model is ready with the trained data, we'll try to test the model with test input. Okay, so okay, I'm taking one more cell now, and we'll try to see it. Okay, so this is the prediction results. We got 68 and 56. Okay, what actually we need to get, that is in y test, right? As we have already have split it. See, so y test. Now we'll see what actually is y test. We got prediction results, but now we'll see what is actual result. Yeah, there is 172 and 10, but this model gives very, like, there is some result, but we can't say it is accurate. It is very uh, like it's deviating very along, right? I'll say why the results are like this. Okay, we'll try to plot it, and we'll see why the results are in this way. Okay, I mean, I'll print everything. Okay, so for the age group of 30 and for the age group of 90, we got these results. Okay, and we'll see why the results are like this. Okay, in a graph. So for that I'm using matplotlib. Okay, now I'm giving x train and y train. Okay, and I'm trying to plot it. Okay, with a blue color, with the age and confirmed cases. Okay, so this is the model which we got, blue. Okay, so as per this, now I have said you like model, right? So model is nothing but this line. Now this is our model. Okay, the blue line which you are seeing is our model. So uh, this rule says, like, if it is age of 30 or around, you can go here and you can see it is around 70, right? So we have got this result. Okay, which is 69 or 70. And if you take around 90, okay, it will be here 90. Okay, if you take here, it will be around 59. Okay, so this is the data we got. Okay, so whatever the data we take here, it will be around this model itself. Okay, so this is the linear regression. Okay, which says we says, like, a linear regression is nothing but to fit a line in our data. Okay, so we can able to fit this line in this way, or in this way, on this way, any way we can able to fit this line. Okay, but the line have to give us the optimum results. Okay, that's what will happen in linear regression. Okay, now as we are using this model, predefined model, we didn't understand what actual algorithm it have undergone, and what are the slope of this line, and how, with what rule it have drawn this line, we don't know, right? Now we'll actually see how the algorithm works. Okay, so this is that algorithm. Regression is nothing but fitting a line. Okay, so as you can see, these blue circles are the data. Okay, for example, I am taking a sine of 2 pi x plus noise, which is Gaussian noise. Randomly there is some data. Okay, and this green line which you are seeing is the desired line or curve, I can say, which we are which we try to fit to our model, but we can't directly in the first go, we don't know how to fit proper line. Okay, so now let us suppose this red line. Okay, so equation of that line is y equals to mx plus c, as we know everyone. This y equals to mx plus c I can convert into in this way. Okay, consider c as w naught and m as w1. Okay, so this is the equation of a line. Now depending on these weights, nothing but the slope and the quotient or x quotient, the line will be changing, right? If it is a straight line, the slope will be 0. Okay, so now we have to create a model from a straight line. It have to increase or decrease its slope, okay, or its weights. Okay, it have to change its weights, and continuously it have to check the result. Okay, so that the result so that the error is reducing as much as possible. Okay, I'll you can see here, right? So for example, all these blue cross marks uh, uh, are the data points. Okay, now initially we don't know where to draw a line. Okay, so what we'll do is we'll start with a slope of 0, which is a straight line with x-axis. Then we'll try to increase a slope and x coefficient so that the line adjusts properly. Okay, so here we are continuing till 30 iterations. Okay, so step by step we are increasing, we are changing its weights, and till 30 iterations we have got some result. Okay, so that is what we have to do actually. That is what is being happening in that model which we have just seen. Okay, now we'll try to create that model. Okay, now you can even think why to draw a straight line. Okay, we can draw some curves, or like even very like very complex curve we can draw. Okay, so exactly if you are using some complex curves, okay, it can exactly fit the data 100%. It will fit the data, and for the test sets will get 100% results. But what about for the trained sets, we'll get 100% result, but we can't get exact results in the test data. Okay, now we'll see if the slope is 0. Okay, so it will be a straight line. Now for example, if uh, okay, if the data is somewhere around, we'll get some errors. Okay, so for that we have increased a slope. Okay, with m1. Okay, nothing but first order, so it will be a slope. Okay, with third order it will be like a curve. Okay, with ninth order, okay, it is very complex a curve. Okay, so as you can think, if you are increasing the order, we can fit the data, but as we are increasing the order, the weights will be increasing more and more. Okay, as the weights are increasing more, okay, we can't get exact data. Okay, so what we shall do is, now for example, we have increased the weights till weight 0, weight 1, weight 2 to mx. Okay, nothing but m order, so that I can that we can able to plot it in this way as a mathematical model. Okay, and now we have to find what is the error. Okay, if you are drawing that kind of curve, what is the error? So this is the equation of that error. Okay, I can show you this here. Okay, now for example, this red one is our model. Error is nothing but the difference between output, nothing but that blue circle to the intercept of red circle. Okay, so that is error. So now you can calculate that error of each point, all the points you can able to calculate the error, so you can get overall error. But the problem here is sometimes the error gets cancelled. Okay, because here the value is in positive, the first sample, and the second sample the value is in negative. Okay, sometimes these two may get cancelled. Okay, so we won't be getting exact result. Okay, So that's why what we have take is, we have to take in this way. Okay, we have to normalize, and then 1 by 2 sum of this is actually what our model says. Okay, a model like y of x of n comma w is nothing but the point in our model, minus t of n is nothing but the output. Okay, so now we'll be squaring it, so that if you are squaring, then we can able to reduce the cancellation of this error. Nothing but even if it is in positive or negative, if we square it, it will be in positive, so we can able to get overall error. Okay, so that's what I will do, root mean square. Okay, so that's what the error. So this is the formula of error. Now what we have to do is, we have to create a model with this formula. Okay, and with this formula we'll try to draw one line, straight line for x-axis, and we'll get some error, EMS error, and that error will try to reduce continuously for so many iterations, maybe 100 or 1000 iterations, and we'll try to fit a line. That's what our model. Okay, now you can even say one more thing. There's one more way, instead of doing all this, we can even give more data. Okay, for example, if there are 15 samples, it is very difficult to form a model, but there are 100 samples, then we can easily find a model. Okay, for our data, but every time it is not possible, right? Because even for some of the data set, for the increasing number of data sets, there will be more deviation. Okay, nothing but it will be more zigzag. Okay, there won't be any proper order for it. So if you are even increasing the data, sometimes we can't get the actual curve fitting. Okay, so for that what we'll do is, we'll try to do regularization is nothing but, you will be for the error whatever you are getting, you will be adding the transpose of it. Okay, nothing but you'll be seeing that in other dimension, so that you can easily find out, you can easily fix the line. Okay, so regularization in one way I can say, like if you are viewing a graph in one dimension, for example, this one. Okay, if the data is very random, the right one which you are seeing, right? So if the data is very random, if you are viewing the graph in one axis or in one dimension, if you are if it is very difficult to fit your model, if you are changing the dimension, okay, then you can able to properly see the data there, you can fit the line properly. That's what regularization in general terms mean. Okay, so with all these formulas, now we'll try to create a our own model. Okay, and then we'll try to customize these, and we'll try to improve the results. Okay, even we can able to improve the results than which are been already existing. Okay, in scikit-learn already it have been these models have been developed. Okay, but we can able to get more accurate results than compared to them. Okay, if the model is our own. Okay, okay, so now, to say in one word, now what we are going to do is, we will be trying to change the weights. Okay, we will be trying to change the weights, and we'll try to create a model. Okay, okay, so I'll take some 5 seconds of a gap here. If you are having any doubts, you can ping, else we'll try to continue. You can ping in the comment section. Okay, so yeah, this is what the result we have got. Now we'll try to create a model of our own. Okay, so this is the formula just now we have seen, right? A root mean square. So where h of x is nothing but uh, the point in our model, and y of I is nothing but which is the output. Okay, so we'll try to create a function that will in general terms we'll say it as a cost. Okay, so the cost or error have to be as less as possible. That's what it is. So x dot, we are taking theta, So square error predictions minus y, nothing but this is our prediction, our model prediction, minus y actual output, we are squaring it. Okay, and finally we are doing root mean square. So we have created a function here. Now what we'll try to do, we'll try to pass our data to this function so that it returns us the what is the actual error. Okay, it won't directly pass any results to us, it directly passes how much error our model is contained, and we'll try to reduce that error. Okay, so similarly as above we have discussed, we are having x and y. Okay, same data, serial number and a percentage of uh, positive cases, and I'm running this model. Now we got error as some 3700 and 3973. We'll try to reduce that error. So to reduce that error, we are having gradient descent. Okay, so gradient descent is one such feature where you will try to take the differentiate. Okay, and you'll try to reduce that error with very minimum quantity as it is possible. Okay, so there is a function gradient descent. Okay, so the arguments to that we are providing is xy, and will provide theta, which is nothing but a small change. Okay, so with this change how much percentage we can able to reduce. Okay, so initially we'll try to give theta, as we don't know what theta value, optimum value of theta, will give 0.01, let it be, we don't know. So instead of 0 we'll give 0.01. Okay, and we'll try to continue for 1000 iterations. Now this returns us theta and its history. Okay, that I've plotted here. Yeah, so here we got a theta value as 94.89. Okay, so even you can able to increase it to 2000 iterations. So for 2000 iterations we got theta value as 107.74. Now here the problem is if we are overrunning it. Okay, so theta value as it is continuously changing, previously it is 97, it is 107, right? Even if I'm increasing to 6000, yeah, even still it is same. So this must be the optimal thing. So I'll take this result, I mean like this theta, okay, as an input, and I'll try to uh, execute what is the error percentage. Previously error which we have got is around 3000, right? That's nearly 4000. Now with the new theta how much error we can able to reduce, that we'll see. Okay, so that is the theta now 107. Yeah, we have reduced from nearly 4000 to 1374. Okay, so now we got our model. Okay, so with this xy and for this data as low as possible. Okay, now we'll try to visualize our results. Okay, in order to see the results in 3 dimension I'm using this library. Okay, so we need as theta 0 theta 1, it is nothing but in y equals to mx plus c. Okay, so this is x and it is sorry, it is m and it is c, nothing but weight 0 and weight 1. So those two things I'm trying to plot in j values, and in the range of theta values. Okay, I'm continuously trying to plot this weight 0 and weight 1. Okay, so that weight 0 and weight 1 will continuously be applied to our cost, where we'll get these results. Yeah, in 3 dimension as we can see. Okay, so we have executed over 5000. This is actual theta and these are weights w naught and w1. Okay, or I can say theta naught and theta 1. Okay, so these are weights, as the weights are increasing with like the change of weights with respect to number of iterations. Okay, so in this way we have fine tuned our model. Okay, so with these fine tuned we will try to plot the results. Okay, yeah, so so run. We'll try to re-execute it once again. So this is the data, and this is the actual how we are viewing the data. Then this is what we needed actually. This is the predicted output, and we'll try to. I'm just rewinding it once again. This is the cost function which we have created on our own, and initially we got so and so value 3,773 with a gradient descent. We'll try to get a new theta. Yeah, here we can see actually how the error is getting reduced. So initially from 3,900 the error is getting reduced, okay, and finally it got settled till 3,000 sorry 1,300 around, okay. So in this way we are reducing the error, okay. So as the error is reducing, accuracy will try to increase, okay. So now even if we try to increase the iterations more than 5,000 also, the result might be same, okay, as we can see here. So that's why we'll stop that till 6,000 iterations, and for now we have designed a model. For this model we'll try to see what is the best fit, okay. Now again I'm taking the same data like serial number and total number of cases, okay. Now I'm getting x and y values, okay, that I'm trying to plot. Okay, so we can compare our results with scikit-learn. In scikit-learn, we can will try to see the line. Okay, it is more straightened. Okay, so this is our result. The red mark which you are seeing, right? This is our result with the model which we have just created. And I'll show you the result in scikit-learn. Yeah, this is what the result we have got. So if you're using the predefined models, we can't able to get the accurate result sometime. We have to do some fine tuning. So what we have just did is we have just aligned this line more into the slope more. We have increased that slope so that the output will be more accurate. Yeah. Okay, this is our own model. So we'll try to predict something. Okay, now for example, this is our prediction model. As I have said, we'll be using regularization, nothing but I will be adding a transpose to it. With that, we'll try to for 45 age, I'm giving 4.5, nothing but how many people got infected around the age of 45. That's what our prediction we needed. Okay, I'm running. So it is 76 members nearly got infected. Okay, with the age of 45. Okay, so this is with one variable. Okay, nothing but we are taking age and number of people got infected. Okay, but the data might be even more complex or huge data, right? For example, now we'll take multiple features. Okay, not one feature. Previously which we have seen is like y equals to mx plus c, that's it, a straight line. Okay, now if there are more features, okay, so I'm having one more data set here. Now we'll see for multiple, okay, multivariable linear regression. Now we'll try to have a look how the data is. I have to minimize it a bit. Yeah, so these are actually data of overall India. One moment, let me project it properly. Let us take only five. Yeah, this is the data which we have. This is a new data set. Now, for example, around India, why I can't expand? Okay, so around India, we have serial number, date, time, and state, if they are from India or if they are from foreign, and how many have queued, and how many have death, and how many have confirmed. Okay, so with this data set, we'll try to create a model. Okay, like we'll try to make a model for how many people have queued and confirmed. These deaths are depending on queued and confirmed, right? So if we'll try to take queued and confirmed in x-axis and deaths in a y-axis. Okay, and we'll try to predict outcomes, like how many people are going to die. Okay, with that, what outcomes we'll have is so and so state cure percentage is not good, that we can able to have. Okay, so this is a complex data, right? We can't able to directly say who are which state is curing properly. Okay, or there's no relation directly which are confirmed, cured, and deaths. Okay, we'll try to predict that. Okay, so we are describing the data like this, and we'll try to have a look of data, like how many states it got in. Sorry. Yeah. So these are the states where corona got affected, and now we'll try to plot all the states and see the results. What we have actually did here is we have got a list of states, right? So in that, for each state, okay, we'll try to take how many people got cured, how many deaths have happened, and what are the dates when they have got infected, and how many got confirmed with corona positive. And that will try to take into a variable, and we'll try to plot using a plotly. Okay, because as we can't directly, like here what I want to do is I want all of these, like queued dates and confirmed and also dates, all have to be clubbed into a one chart. Okay, that we can't do it directly with the matplotlib. So I'm using plotly here for easy of use. Okay, maybe I'll show this. Yeah, we can see in each state. In Chhattisgarh, like the blue one is confirmed, and red one queued, and green one death. Okay, these are the percentage in Jammu Kashmir. Okay, in x-axis you can see the date: Madhya Pradesh, Gujarat, Bihar. So in this way, we can represent the data. Okay, so now we'll try to pick any one state and we'll try to predict the results. Okay, okay. So I'm picking Telangana state, and in that, how many queued and the dates, deaths, and confirmed that I'll be taking, and we'll try to plot the results. So this is how it looks like. There are like more than 1,000, like nearly 1,000 cases got reported in Telangana, and as of I'll say the date, as of April 26th, I got we got 367 got cured, and around 26 got death. Yeah, so this is the data. Okay, now this is the normalization. We'll try to take one function normalization in order to reduce the standard deviation. Okay, because if the data is very random, just like we have seen here, right? If the data is very random, it's very difficult to fit to any model. That's why we have to do normalization. And now what we'll try to do is we'll try to take our features. Okay, so what I'll take in X is I'll take 6 and 8 columns, and in Y I'll take 7th column. So nothing but we'll go back to data again. Yeah, here. So I'll try to take queued and confirmed as an x-axis and depth in a y-axis. Okay. In the same way, you can even take multiple features like confirmed Indian or foreign. Okay. So here I've took only two features. You can even extend it to whatever the model, whatever the data set you are having. Okay. So so after normalizing, so this is how the data looks like. Okay, so it is not exactly as the data which we have given, but after normalizing, nothing but in order to reduce the standard deviation we have used this. So it will be fixing more data into the mean value. Okay, so as I remember, we have used this cost function, right, previously. Okay, now similarly cost function we have here. So we got some error as 75. Okay, now we'll try to again reduce this 75. The error is 75, right? So we'll try to reduce the error whatever is possible with gradient descent. After reducing that error, we'll try to fix the data to our model. Okay, that's what previously which we have did. Okay, so initially theta we have given 0.1. Yeah, so the error previously which we have got around 70, right? It have been adjusted to 1. Okay, so the error got reduced so much more. Okay, yeah. Now as the error is reduced, now we'll try to predict. Okay, so we try to predict the x with the, input as theta. Now for example, the number of queued people are triple one, and active cases are like uh, 562 in Telangana. So the predicted deaths will be 10. Okay, so if you are taking some other state, the deaths will be, they might be more, right? If you are taking some other state where like for example in Maharashtra, Okay, if you have took Maharashtra with the so and so queued people and so positively active people, and then we can able to see how many percentage of deaths can happen. Okay, so with this we can actually compare all states, and we can see which state is uh, doing efficient work in order to reduce the corona deaths. Okay, so yeah, so here I can end the discussion on machine learning here. So what we have learned is we have learned how to take the data and how to process or plot the data. And after plotting, initially we have seen how to uh, take a model from scikit-learn and to predict output from scikit-learn. And as the results are not accurate in scikit-learn, we have created our own model. Okay, so we have seen age versus number of positive active cases, and we have designed one variable linear regression. And as the results are proper, then we have with the same model we have took two variable, and there using gradient descent, okay, we have reduced the error from 75 to 1. Okay, so that's what I can show you. We have reduced initially by applying the same linear regression model. Okay, so initially the error was 1, but by using gradient descent the error got reduced, right? So from 75 it got reduced to 1. Okay, so I can't say 1, like 0.5 or 0.1 around. So we have reduced huge error percentage, and as the error got reduced, the results are more accurate. So for so and so queued and for so and so active cases in Telangana, these many peoples are getting died. Nothing but nearly 11 people out of these many active cases, out of 562 active cases, these many peoples are going to die. Okay, so this is only one algorithm which we have discussed, which is linear regression. In the similar way, there are many number of algorithms. Okay, so I suggest you can go through the scikit-learn, and there are a lot of models available. Now you can able to try each and every model, and you can able to make a comparison of all these models and see which model is having more result or more accuracy. Okay, and in the similar way you can able to compare all the states, and you can able to predict the death percentages are less in so and so state. Okay, we can't directly say like for example in Maharashtra, generally now in Maharashtra and Delhi the deaths are more, right? So we can't directly say the government is not doing a proper job there, because as the population of Delhi and Maharashtra are more than comparatively other states, for example like uh, Kerala or some other union territories. So we have to use this machine learning, and we have to see the percentage of deaths when compared with the positive and queued, and then we have to make a prediction as which state is doing fine. Okay, and okay, so this is what a machine learning model which we have applied, and I guess this will be the session. And furthermore, we will be having more webinars coming in through. But still, if you are having any queries or anything, you can always you can give a mail in training@pantechmail.com, or you can reach us in these numbers. And there are not only these, there are a lot of tutorials in all the technologies which are already being present in YouTube channels. And not only this, you can even in YouTube you can able to see uh, corona diagnosed results, like there are two image samples, and the project the scanned report, the comparison of scanned report is available. If you are in machine image processing with machine learning, you can even visit that, and stay logged into Pantech in order to have more webinars. Okay, if you are having any doubts, you can again pass in comments for next 15 or 20 seconds. Still, again, I'm saying if you need any more documented based uh, queries, you can always mail to us. Okay, I'll be waiting for next 2 minutes at least. If you're having any doubts, you can obviously pass in a comment section. It also like uh, mostly for colleges, if you wanted to conduct any webinars currently from your college, because it's been locked down everywhere, right? So if you want to conduct more webinars from your college, you can always contact to the given number, or you can mail here. And even after that, if you need any like direct sessions, interactive sessions, even after lockdown, you can able to contact us. Okay, and I'll pass uh, okay. So from your college, this webinar is from IETE with Pantech. So if you want to conduct any webinars or any workshops related to any field in engineering, it could be electronics, electrical, computer science, machine learning, AI. So you can contact these numbers. Okay, and also upcoming programs will be on IoT with same IET based webinars. You can get subscribed to Pantech Solutions, and you'll be getting alerts later on. But if you needed any such webinars, or not only these things, if you suggest any suggestions are welcome. Uh, so the contact person for this is Mr. Srinivasan. You can right now call him. or anytime if you were intended to take any workshops. Okay, still I'll be waiting for 30 more seconds. If you are having any doubts, please do ping in the comment section. And also regarding the certificates, if you needed IETE based certificates for today's program, uh, that also you can able to pass in a comment section with your details, I mean like your mail ID and your college details, and your full name. Okay, so I'll end this session myself, Rahul Yennu. So if you're having any doubts, I'll be waiting to clear them in training at pantechmail.com, or you